Welcome to video lecture. Myself Ashwini RK, Assistant Professor, Rogni College of Engineering and Technology. Today we are going to see about boundary layer theory. The concept of boundary layer was first introduced by L. Brandlett in 1904, and since then it has been applied to several fluid flow problems. No slip condition occurs when real fluid passes over solid body or wall. In the immediate vicinity of the boundary surface, the velocity of the fluid increases gradually from zero at the boundary surface to the velocity of the mainstream. This region is known as boundary layer. When the fluids flow over surfaces, the molecules near the surface are brought to rest due to viscosity of the fluid. The adjacent layers are also slowed down due to the lower and the lower extent. This slowing down was found limited to a thin layer near the surface. The fluid beyond this layer is not affected by the presence of surfaces. The fluid layer near the surfaces, which there is a general slowing down, is defined as the boundary layer. The velocity of the flow in this layer increases from zero at the surface to the free stream velocity at the edge of the boundary layer. When a real fluid flow passes a solid body or solid wall, the fluid particles adhere to the boundary and conditions of no slip occurs. This means that the velocity of the fluid close to the boundary will be same as that of the boundary. If the boundary is stationary, the velocity of the fluid at the boundary will be zero. The theory dealing with the boundary layer flow is called as boundary layer theory. According to the boundary layer theory, the flow of fluid in the neighborhood of the solid boundary may be divided into two regions as shown below. The simplest boundary layer to study is that formed in the flow along one side of a thin, smooth, flat plate parallel to the direction of the oncoming fluid. No other solid surface is nearer and the pressure of the fluid is uniform. If the fluid were inviscid, no velocity gradient would in the same instance arise. The velocity gradients in a real fluid are therefore entirely due to viscous action near the surface. The fluid originally having the velocity in the direction of plate is retarded in the neighborhood of the surface, and the boundary layer begins at the leading edge of the plate. As more and more the fluid is slowed down, the thickness of the layer increases. The fluid in contact with the plate surface has zero velocity, no slip, and a velocity gradient exists between the fluid in the free stream and the plate surface. The flow of the first part of the boundary layer close to the leading edges of the plate is entirely laminar. With increasing thickness, however, the laminar layer becomes unstable and the motion within it becomes disturbed. The irregularities of the flow develop into turbulence and the thickness of the layer increases more rapidly. The changes from laminar to the turbulent flow takes place over a short length known as transition region. Thank you.